Assalamu alaikum everyone. Today we are presenting our project on basic intruder alarm system built using the widely used 555 timer. These are my teammates. First, there is MD Jairul Islam Nahid, then Jihadul Islam, then myself Sheikh MD Ashikar Rahman Titash, and then Tahiyamin Sharkar. These are the contents of our project: introduction, components, intruder alarm, simulation, discussion. So let's move on to our first slide. The first slide is about 555 timer. What is a 555 timer? It is a fundamental component in electronics. The 555 timer IC offers a reliable and well understood approach to gathering precise timing signals. This compact and versatile integrated circuit finds application in various electronic projects, including oscillators, pulse generator, and timers. Moving on to our second slide. Here we will be talking about pin configurations of a 555 timer IC. These are all the 8 pins of a 555 timer. The 555 timer IC, a cornerstone of many electronic projects, boasts a simple yet powerful pin configuration. With just 8 pins, it unlocks a world of timing possibilities. Grounding pin on number 1 ensures proper operation. Trigger input on pin 2 initializes time cycles, while pin 3 serves as the output, faithfully delivering the timed signal. A reset pin on number 4 allows for manual control over the timer's state. Pin 5, the control voltage pin, offers advanced users the ability to fine-tune timing behavior. Then pin 5, the control voltage pin, offers advanced uses. Then threshold detection happens on pin 6 and pin 7. The discharge pin plays a key role in the timing cycle. Finally, pin 8 proves and provides power to the IC, bringing the timing mastery to life. Understanding these pins is the first step to unlocking the creative potential of the 555 timer. Moving on to our next slide. Modes of operation of a 555 timer. There are 3 modes: astable mode, monostable mode, and bistable mode. So let's start with astable mode. Imagine a self-starting swing set. In this mode, the timer continuously flips its output between high and low, creating a continuous square wave perfect for flashing lights or building clocks. Moving on to our next mode, monostable. Think of a one-shot timer. Trigger the 555 timer with a pulse and it delivers a single timed output burst, ideal for delays or triggering other circuits. Bistable. Picture a light switch. This mode turns the 555 timer into a flip-flop, changing its output state high or low each time it receives a signal. Perfect for building electronic switches or logic circuits. So that's all for my part. The other parts will be presented by my teammates. Thank you all.
My part is to describe the charging phase of the capacitor C1. The circuit includes the following components: a 555 timer. This is the integrated circuit that generates the oscillating signal. Resistors R1, R2 and RQ. These resistors control the timing of the signals. And capacitor. The capacitor stores the electrical energy and helps to determine the frequency and the output waveform. Switch. The switch is used here to turn the circuit on and off. Power supply VCC, this provides the power to the circuit. The circuit works by charging and discharging the capacitor C1 through the resistor R1, R2 and RQ. When the capacitor is charging, the output voltage is high. When the capacitor discharging, the output voltage is low. The timing of the charging and discharging cycle is collected by the values of the resistors and capacitor. Resistor R1, R2 and RQ. When the capacitor is charging, the output voltage is high. When the capacitor is discharging, the output voltage is low. The timing of the charging and discharging cycle is controlled by the values of the resistors and the capacitor. The switch is used to turn the circuit on and off. When the circuit switch is on position, the circuit is powered at the output will oscillate. When the switch is in the off position, the circuit is not powered and output will be low. So output of the comparator A equals 0 and comparator B equal 1. Now C1 begins charging through R1 and R2. When the power is just turned on, the capacitor C1 remains unchanged. When C1 is greater than one-third of VCC, output of the comparator B is 0, but the output is still 1, but it unchanged. Now I would like to describe the discharging phase of the capacitor C1. In this diagram, power up and the initial changes. When we turn on the circuit, the capacitor C1 stayed and unchanged. This triggered the 555 timer of output a high voltage VCC in the pin 3 2. Capacitor changes. While the output is high, current flows through resistor R1 charging capacitor C1. The voltage at pin 2 connected to C1 gradually increases. Threshold reset and output switch. Once the voltage at pin 2 reaches two-thirds of the supply voltage VCC and the 555 timer output flips to low 0 volt. Capacitor discharge. Simultaneously, a path opens for C1 to discharge through resistor R2. The capacitor voltage at pin 2 starts discharging. Registering and counting oscillation. At C1 discharge through R2, the voltage at pin 2 falls. When it reaches another threshold one-third of VCC, the 555 timer's output flips back to high, recharging C1. The cycle is recharging and discharging C1 based on voltage thresholds at pin 2. Continues identify creating a continuous stream of the square waves of the output at pin 3. The timing of the output square waves, high and low pulses, determined by the values of resistor R1 and R2 and capacitor C1. By recharging these components, we will adjust the frequency and duty cycle ratio of high time to total period of the output waveform. So once C1 reaches beyond two-thirds of VCC, comparator A becomes 1. Capacitor starts discharging, the resets and the flip-flop and the Q1 gets turned. Therefore, during this discharge phase, the output of the 555 timer is 0. We get the output of pin 3 or out is 0. So I will now discuss about the components. Here is the components part. We need a ICNE 555 timer. We need 7.2 kilo ohm resistor, a 3.6 kilo ohm resistor and a 100 kilo ohm resistor. Also we need a interactive SPST switch, one speaker, one capacitor and 0.01 capacitor we need. Thank you everyone.
Assalamualaikum everyone, I'm Jadul Islam and now I'll be continuing from this part. So let's talk about the alarm system. So our project is basically about detecting any unwanted noise in a place. Once someone triggers the alarm, it will go off right away. Here is a simple diagram showing how our alarm system works. At the start, the switch is on and the reset is active, so the alarm is ready. But when someone triggers the alarm, the reset will be disconnected from the ground. Then the timer starts working and sends signal pulses to the speaker. In a basic mode, the output of the initial model generates these pulses. As a result, the speaker gets the signal and emits sound. Next, we'll look at how we set up the hardware. You can see all the parts connected as needed for everything to work smoothly. Now let's watch the video of the hardware circuit.
So this is the hardware implementation of an Intruder alarm. Utilizes a 555 timer powered by a 9-volt battery. The VCC terminal of the 555 timer is linked to the positive rail, while pin 1 ground is connected to the negative rail. The reset pin of the 555 timer is also connected to the negative rail. Upon detection of an intruder by the motion sensor, the reset pin of the 555 timer is briefly connected to the positive rail. After that, the alarm, consisting a buzzer and LED, stays on until reset by the appropriate authority.
Now I'll be explaining the simulation and circuit part of the project. So first let's examine the circuit. So here we have a VCC, a DC generator connected to the timer to provide necessary power. Then there is a interactive switch controlling the timer reset. Next we have the speaker connected to the output pin of the timer. This pin is the reset pin of the 555 timer IC, and it's crucial for this project as we can manipulate the timer with this pin via a switch. Now moving on the circuit simulation, let's see what actually happens.
Assalamu alaikum, sir. Let me introduce first. My name is Yamin Sharkar. I'm doing my BSc in Computer Science and Engineering. As you can see, we made a intruder alarm using 555 timer. My group member were discussing previous slides, and now I'm going to talk about discussion and limitations. The project was finished with the aid of a 555 timer operating in a stable mode. During project work, we learned how the stable mode works. This allowed us to use the 555 timer in a real-world project in a way that was both educational and enjoyable. We faced some challenges and limitations. Challenges and limitations are: first, components. During project implementation, it may be difficult to get precisely rated resistor and capacitors. False alarms. It is important to maintain a low false alarms rate in order to avoid needless interruption and user desensitization. Privacy concerns. It's important to strike a balance between security and personal privacy. Intrusion detection systems have to be careful not to invade people's privacy or gather too much information. Reliability of the system. Reliability of the operation is essential. The system needs to be resistant to outside influences, power disruption, and possible manipulations. Ethical use. Irresponsible implementation of technology necessitates openness and unambiguous user communication on the goals and functionalities of the system. Disturbing alarm sound. When sounding warning, it may produce unsettling noises. This might result in needless confusion and irreversible loss or damage to hearing. The project is not intended for this use. We must confirm that the alarm's sound frequency falls within the spectrum of calming tones. The last one is the future directions and innovations. The environment of Intruder alarm system is always changing due to developments in artificial intelligence, networking, and sensor technologies. By improving the system's capacity to distinguish between allowed and illegal activity, machine learning algorithms can lower the number of false alarms. All-encompassing security solutions are provided via integration with other some smart systems, such access control and security cameras. Thank you, sir. That's all.